The big thing that we've got to remember throughout all of this, guys, I'm going to constantly ask you this every single day. What is a mole? It's a counting unit. So if I said dozen, you would tell me what's on the front page, the very first page of your note packet. Okay, down there at the bottom. What's a dozen? 12. What's a baker's dozen? 13. What's a ton? 2,000. If I said a mile, how many feet would that be?
5,280.
5,280. So guys, we have all of these units, and we've already looked at it, right? Because we've done conversions already this year, where we ascribe different names that represent things, and that's all a mole is. Okay, a mole equals the same amount of a substance that contains exactly the particles as there are atoms in exactly 12 grams of carbon. So this is based on carbon-12. Right? Why is it based on carbon-12? It's probably the most common isotope that we run into. We have it in our bodies, all right, because it makes up everything. All right? So remember, it is a counting unit that equals a number. Okay, so we will count by moles, excuse me, but then we can convert to how many atoms or particles they are. We can convert to grams if we know how many moles we are. And this is what chemists use on a day-to-day basis. When I was in grad school or when I worked at Kodak, we were using it all the time. All right? So it's super, super important. It's a constant. It is 6.02 times 10 to the 23rd. You guys will memorize this number. If not, I'll keep playing the song for you. Eventually it'll stick. All right? So the faster you memorize it, the less we got to listen to it. Mole Day, I got like tons of songs. So just be ready. Just be ready. All right, so guys, we've talked about conversion factors. Okay? We can use Avogadro's number as a conversion factor. So I believe now we are at the top of page 2 in your notes. Okay? One thing I want you guys to note, it could be anything. These 5 items right here, okay, these 5 are the common units we're going to see. I want you guys to write these down in your notes next to examples, or you already have them there, so make sure you know those. Add particles to it as well. It's just telling you kind of how specific of a piece it wants to be. When we get into bonding in a couple of units, you will see all of these names together. We know what atoms are. Atoms represent a single element. Particles are just a general term. They could be anything. Ions. What do ions have, guys? They have charges. Because they have a different number of what? Thank you. Oh, I was going to say, we just had a quiz. Electrons. Molecules, guys, and formula units. These two terms will make more sense when we get into bonding. Those terms will tell us what type of bonding is taking place, whether it's covalent or whether it's ionic. Again, that comes later on. Okay? So examples. 1 mole could be 6.02 times 10 to the 23rd atoms or ions or molecules. When we make a conversion factor, this is what you guys started doing yesterday with that lovely worksheet with, you know, the swizzles and frizzles and all that stuff, okay? I'll tell you the answers to it in a little bit. Do these conversion factors, guys, have to stay in this order, like with mole on the top and ions on the bottom? Absolutely not, right? We can switch them and flip them. It depends on what we're given and what we're looking for, okay? So as we go through that, why don't you guys get your worksheet out from yesterday? I'll run through the answers really quick. So let's jump into some practice, guys. We want to figure out how many molecules are in 2.0 moles. Okay? So we've got to figure out first, what's a conversion factor that relates molecules and moles? Are they directly related? I see some shaking the head. No, they're not directly related. But what if we look right back on the last page that talks about conversion factors, or my last slide at the top, guys? Are those two things related? Yes, they are. Notice, just as an FYI, guys, moles is abbreviated a lot of times as MOL. Molecules, if you abbreviate molecules, make it molec. Okay? But why they abbreviate it MOL, it just is what it is. It's only getting rid of one letter, I get that. Just make sure you know that. So, we have a conversion factor that relates moles and molecules. So now, let's just go through and set up our T-chart. There's my given. What goes below my first fraction always? 1. Now, there's only one time where something else would go there, is if you have a double unit, like miles per hour, grams per milliliter. We don't have moles per anything, guys. It's just moles, so we're putting a 1 there. Now, do I want to stay with moles? Am I trying to end with moles as my unit? No. What am I trying to end with? Molecules. So that means I need to cancel moles out. Where does it have to go to cancel out? On the bottom. Mole on the bottom. What's going to be on the top then? Molecules. Cross out moles, guys. Notice how I'm doing that. Notice also, have I done anything with my numbers in my new fraction yet? Get your units set up first. That's what I was saying back in Unit 1. Let your units drive your math. Set your units up first, because now all we have to do is go back and look at our conversion factor and pair up the numbers. Okay? It said that 1 mole was 6.02 times 10 to the 23rd molecules. So now we're going to go over here and we're just going to fill it in. 1 mole, 6.02 times 10 to the 23rd molecules. Is that the unit I want to end with? Put a circle around it. You know you've gotten to your target. So now all we have to do is do the math. Oh boy. Multiplying by scientific notation. Let's go do a recap for that. How many sig figs should I round my final answer to, guys? Why 2? That's how many were given to us in the beginning. So my final answer is going to be 1.2 times 10 to the 24th molecules. If you don't put your unit, you will lose points. Okay, just like all along so far this year. I want you guys to do the next 2 problems on your own. Okay? Same as the example we just did. Now, as I'm going through this, do you think that it's always going to be set up the same way as these 3 problems? No, okay, because it depends on what you're looking for. That's how you should set up the second one. When you get your answer, it should be what? 9.0, because it's not going to round, it's like 9.04, I think. Okay, times 10 to the 23rd molecules is what you should have for the second one. So you're doing something wrong with your calculator. I'll come and check it in a second. Okay, same way here. Cross out moles. 6.02 times 10 to the 23rd. Here you should have like 4.52. So 4.5 times 10 to the 23rd molecules is what you should have there. Okay? Laura. So all of those problems, we were going from moles to molecules. Now we're going to be going from molecules back to moles. Okay? So, now I know the units are not here, so put molecules for both of those. Okay? It's asking you for how many moles? Same process. Set up your T-chart. What goes below my first fraction? Okay? What unit's going to be on the bottom now? Molecules will be on the bottom. Moles are going to be on the top. So you've got to think to yourself, where do my numbers go? Okay? When we were looking at our conversions in the last one, bless you, okay, mole always got the number 1. So that's something you've got to remember, guys. Mole should always be the smallest number. Okay? If you think about it, 1 mole equals 6.02 times 10 to the 23rd. So when you're trying to get to an answer of moles, moles will always be the smallest number you should have in a problem. If you get something gigantic, it doesn't make sense mathematically. Jot that note down off to the side somewhere, is mole will always be the smallest. Okay? So within a problem, moles will always be the smallest. If you don't get that to be the smallest, you've done something wrong. Chances are you flipped where your Avogadro's number should go. So on the bottom is where we're going to put that 6.02 times 10 to the 23rd, and then 1 mole should be on the top. No matter what conversion factor we use when we're dealing with moles and something else, mole will always get the number 1. Okay? Now, this, hopefully you don't need a calculator for this one, because you've got the same number right here that you do here. So what's our answer going to be? Nope. 1 mole. You were looking at the second one. Yep. All right. So the second one, guys, would be set up the same way. Molecule would be on the bottom, mole will be on the top. Molecules will cancel out. Set up your numbers after you set up your units. 6.02 times 10 to the 23rd. This one, maybe you can recognize because we already had a problem like it. 1.204 times 10 to the 24th is actually twice that of 6.02. You guys do the you try problem. The other flip side, guys, of how we can relate to moles and how we do it every single day in a lab, because we're not counting out molecules. Okay? We don't have balances or anything that counts moles. We don't have any way to do that. So we have a relationship between moles and grams, which is something we can actually measure in lab. Question? How we measure moles, guys, is using what's called molar mass. Now, that term molar mass has other terms that mean the same thing. It could be gram formula mass. I believe that these are already in your notes. It could be gram mass. It could be formula mass. They all mean the same thing. Okay? The mass in grams of 1 mole of anything, guys, is what our molar mass is. So for elements, the molar mass is just the atomic mass that we find on our periodic table. Okay? So if you have a single element, you just have to go to your periodic table. Bam! You've got it right there. What unit have we called the molar mass so far on our periodic table? What was the unit that we used? When you guys calculated it, when you counted up those things, there was a specific unit that we called it. AMU, right? Atomic mass unit. We're going to have a slightly different unit, guys, for it. It's also called grams per mole. And they're related. Same thing as AMU. Okay? Another conversion factor that's related to mass right here. 1 mole just equals the atomic weight. Okay? So for elements, it's super easy. 1 mole of carbon would be 12.01 grams of carbon. 1 mole of lithium, 6.94 grams of lithium. What's going to be the molar mass of calcium? How would we write that conversion factor? 1 mole of calcium equals what? How many grams of calcium? 40.08. So you should have your periodic tables out because without them, this is impossible. Iron would be what? Iron?
Oh, no, that's the wrong one.
Shouldn't be taking this long. I'm just rounding it to 2 decimal places, okay? So that's it. You just go to your periodic table. It's going to be difficult if you're too lazy to get them out, but that's, the choice that you guys will make. So, we now have 2 conversion factors, guys. We have one that relates molecules or atoms or ions to a mole. And then we have moles with grams. We can use both of them in our conversion process. Okay? So let's jump in. Here we go. It says how many grams are in 2 moles of helium? But before we do this, let's go through and let's actually write down. I want you guys to put this on your formula sheet on table T in your reference packet. Okay, I want you guys to draw this at the very bottom. This is going to be called our mole roadmap. Okay? It's kind of showing how these are related. Okay? What's the link between grams and molecules? What's between both of them that's similar in those 2 conversion factors? What's the piece that's the same in both of those fractions? Mole, right? That's the link between them. So mole, guys, goes in the middle. On one side, we can have mass. What's our unit for mass? Grams. Okay? On the other side, we can have particles. Or any of those other units that we had. I'm going to just make mine a little bit smaller. Okay? Guys, particles could be atoms, could be ions, it could be those other pieces that we talked about as well. So we can go, if we're given one of these 3 pieces, we can get to the other ones. When we come back and study gases, there'll be a 3rd one that we can add in there, so it's a pyramid, not just like a line right here. So if I'm going from mass back to moles, I'm going to divide essentially by the molar mass. Again, this may not all make sense right now, but it's going to be a tool that's going to help you in a little bit. So mm just means molar mass. If I want to go from moles to particles then, I'm multiplying by Avogadro's number, which is 6.02 times 10 to the 23rd. On the flip side, we can do the opposite and go backwards. If I want to go from particles back to moles, well, I'm going to use that same number, but instead of multiplying, I'm going to do what? Divide. And then over here, if I want to get back to mass, I'm multiplying by the molar mass. Bless you. Okay? So this is going to be a great tool. You guys may want to memorize this and write it down on your test when we have our quarter one test, as well as your Regents exam. It's going to be a tool that may make it a little bit easier for you. So let's jump over here. We have 2 moles of helium. Okay, we're trying to get to grams. This is going to be the last problem that we do. Where do I start in this example? Write down what you're given. So I've got 2 what? Moles. Now, is it good enough for me just to put down moles? It's moles of what? Helium. You need to get in the habit right now of putting the substance with it, because when we get back to stoichiometry later on, you're going to be changing substances within the same problem. So make sure you include what substance you have. All right, so we're trying to get to what? Grams of helium. Now, if we take a look back here at our roadmap, guys, I'm starting with moles. So I'm in the middle of my roadmap. Okay? Where am I trying to get to? Mass. So following my arrow, what am I essentially doing to get to my mass? Oh, I'm multiplying. Well, if I take a look here, where does moles have to go to cancel out? Moles has to go on the bottom. And that means grams of helium will go on the top. Cross out moles. 1 mole has how many grams of helium in it? Where do we find that information? Reference table, specifically the periodic table. What's the molar mass of helium? All right, we'll leave it as 4.0. Oh, what am I doing here? I'm multiplying. 2 times 4 is what? So if I have 2 moles of helium, I can measure out 8 grams of helium, and I know I have exactly 2 moles. Okay? So that is exactly what we did. Even though it doesn't look like it, okay, we just multiplied to get to where we wanted to. Your homework tonight is your vocab.